All right, it's Hayden. I'm back. I still don't have a job. This is Leetcode 2780, minimum index of a valid split. We have an element x of an integer array of length m is dominant if more than half the elements of the array have a value of x. Okay. You are given a zero-indexed integer array nums of length n with one dominant element. You can split nums at an index I into two arrays, nums and nums. Okay, split over. But the split is only valid if I is less than n. Okay, that makes sense. And have the same dominant. Oh, and the splits must have the same dominant element. Okay. Here nums. Return. Okay. So this is just going to be a kind of sliding window, I believe. All right, so the first goal is going to be finding the dominant element. Yeah, first order of operations is going to be finding the dominant element. So if we have, let's do the example. Yeah, 1, 2, 2, 2. All right. So we have the example 1, 2, 2, 2. First, we're going to find the dominant element. So we're just going to iterate with a hash map with the counts, hash map, and count them all. We'll see that 1 has 1, 2 has 3, and we're going to store our maximum element, which is 2. So we know dom is 2. Now we're going to go across that same array one more time. And this time we're going to store a secondary array like this, like so. Matter of fact, we don't even need to do this. Because we have this dominant element, we're just going to go through and we're going to compare the counts. All right, so here, I. So how many counts of 2 do we have? 0. All right. How many counts of 2 do we have here? 1. 1 compared to 2, that's not more than half. 2 compared to 3 is 2 more than half? Yes. This is the first index of our dominant split. So we're just going to use this method to solve the problem. So first thing, like I said, we got to do is find the dominant element. Find dominant element. Because we're told that there is a dominant element, at least one, or there is one, there can be in the subarrays no other dominant elements, because that means that the opposite end of the subarray is not dominant, if that makes sense. In short, the dominant element of the whole array has got to be the dominant element of each subarray. All right. And then we're going to simply create our hash map, which is just a dictionary in Python. So counts equals dict. And I'm pretty sure we can do a dictionary comprehension. So, oh, did not mean to do that. So this is going to be let's see, how do we do ChatGPT dict comprehension Python get counts of elements. I thought it'd be nicer. We'll just iterate through. All right, count equals dict for num in nums. We're going to do counts dot get num, and then we're going to default to 0. This is count equals this. And then we're going to do counts num equals count plus 1. All right. This will find our dominant element for us, and or this is going to have our hash map, and we're also, while doing this, going to need to we'll do it this way instead. So now it's find dominant element, get number counts, find dominant number. I don't know why it defaults to that. All right, so we're going to have dom equals -1, dom count equals dom number. We'll actually make this a tuple. So this is -1, -1, where we're going to have num count. All right. For num count in counts.items, if count is greater than dom 1, we're going to do dom equals num count. And then we're simply going to overshadow the variable with dom equals dom 0. So this is just basically ignoring the count of the dom and just making it so that dom is the number. It's no longer a tuple. All right. Next, if we come back, next it's time to do our little counting thing. So we're going to iterate along the array for num in nums. We're actually also going to have to zip this. So I nums in enumerate nums. And we're going to have to maintain dom count equals 0. All right, so if we do not want nums here, this will cause an error. If num equals dom, we're going to dom count plus equals 1. And then we have to check both sides of our potential split. So our potential split is going to be right here at the moment. We're going to check both sides to see if this number is greater, or if the number of dom on this side is greater than. We do actually have to store this count. All right. So dom num dom count equals dom. All right. Cur count. So we're going to be checking both sides. So right now we're checking this left side of 1. So we saw we saw that this was not our dominant number. So we did not increment this, and then we're going to do num plus, or we're going to do a check if cur count is greater than I plus 1, or if 2 times cur count is greater than I plus 1 plus 1. Basically, this equation is just doing this operation for us. So it's checking. It's actually going to put this at the length is 1 of our subarray. So this is a subarray length. And then we're adding 1 just to make sure that this is more than half. So this is just a little bit of math to express that. So this is left satisfies. Then we're going to have right satisfies. And how are we going to get this? So this is going to be 2 times dom count minus cur count. It's greater than len. Where does this nums? Three, so we have to subtract I, subtract 1. So this is the size of this part of the array. And then I think we have to subtract 1 again. We add 1. We don't actually have to have this because these are greater thans. So if cur count 2 times 0, we'll check that later. But okay. If left satisfies and right satisfies, return I plus 1. Return -1. Find valid split. All right, so if we step through this equation, 1, 2, 3, 4, we have dom num equals 2, dom count equals 3. The length of this is 4, so our first iteration we're going to have I equals, I actually like to do this. It helps me think a little bit. So 1, 2, 2, 2. We have I here, so I is at index 0. 1, 2, 3. All right, I is at 0, and then we're going to come back if num equals dom. Is the num here? No. So this is what it is. Cur equals nothing. And I'm going to use tally marks. Cur equals nothing. All right, we know that this won't work, but let's just go through it. Is 2 times cur count greater than I plus 1? So is 2 times 0 greater than 0 plus 1? No. All right, so this automatically is invalidated. Now we iterate to here. All right, cool. Is num equal to dom? Yes. So cur, get a tally there. All right, now does left satisfy? Is 2 times cur greater than I plus 1? All right, I equals 1, so I plus 1 is 2. 2 times 1 is 2. Is 2 greater than 2? No. All right, left does not satisfy. All right, we're going to go one more. All right, cur now equals 2. All right, left should satisfy here. 2 times cur. Cur is 2, so this is 4. And I is at 2, so this is 3. Left satisfies. Perfect. All right, now we got to check if right satisfies. Right satisfies. Right has a dom count. The dom count is 3 minus cur count 2. So there's 1 on the right side. That's correct. 2 times 1, 2. And then the length of nums minus I minus 1. So 4. This is going to be 4 minus 2. 4 minus 2 minus 1. 1. That is correct. There's only a size of 1 on the right side of our split. All right, left and right satisfy. So we're going to return I plus 1. All right, and let's see if there are any corner cases. So 1's the dominant element here. Let's go through this. 2, 1, 3, 1, 1, 1, 3, 1, 1, 1, 7, 1, 2, 1. All right. So dom equals 1 dom count. Wow, it's hard to write with a cursor, actually. Probably why I was bad at Valorant. All right. 1, 2, 3, 4, 5, 6. 6. All right. Here, does left satisfy? Obviously not. No. Here, no. Here, no. Here, no. So this should be the split that our algorithm returns. And it satisfies. I believe there's probably some corner cases, especially because it's I plus 1. I think I have to do a if I plus 1 equals len nums break. Let's see what happens with really strange input. Is this part of it? It has to be at least 1. So the split a split's not possible if the element is of size 0. So that's when we return 1. All right, let's check to see. We're guaranteed to have one. We're guaranteed to have a dominant element, so that's one of them. 1, 2, 1. I think the trickiness could happen. One thing I always try to do is break a system. Okay, yeah, here we go. 1's dominant here, but I don't think we can create a split. Yeah, we can't create a split. Not dominant, or it's dominant here, but not dominant on the right side, so we continue to 2. Now the right side's dominant, but left side's not dominant. And you keep going down until you get to here, and then you're like, oh, I can split. Without the check, our answer would be, what would this be? 5? 0, 1, 2, 3, 4. Yeah, 5, which is wrong. Ooh, why are you not happy? Let's see where we're going wrong. All right, so our dominant number and whatnot are good. Now this is the iteration where it should happen. Left satisfies is false. That would be what's going wrong. All right. Huh. Oh. And that's another part. Num dom. All right, now are you happy? Oh my goodness. All right, and I believe that this should be right. All right. That was Leetcode 2780. Hopefully get a job soon.